next.
Excited about today's show. There are rare ones like this that I just get really jazzed up about. I'm surrounded by people, all these folks behind me, who never thought they'd live to see this day. In fact, they never thought they'd be alive today because they were once dying from cancer. Some were so sick, they were living out their last days in hospice care. They were saying their goodbyes. Now look at them. How did they get here? Some say it's thanks to a miracle pill for cancer. Could this be the discovery that helps you prevent cancer altogether?
I had months to live.
Doctors didn't know what to do.
Treatments weren't working.
Imagine, cancer threatened every one of these people with a death sentence. Instead, every single one of them survived, and they are living normal lives thanks to a special cancer medication some call a miracle pill. The trials for this medication were staggeringly successful. Nearly 100% of patients treated for cancer went into complete remission. The drug is called Gleevec, and it's a revolutionary way to treat cancer. Gleevec targets and attacks only cancer cells, leaving normal cells largely unharmed. A vast improvement over traditional chemotherapy that targets all fast-growing cells and makes patients very sick. Dr. Brian Drucker spearheaded the research on Gleevec, determined to find a better solution for his patients dying from a rare leukemia. His years of persistence paid off. Studies show the 5-year survival rate for patients treated with Gleevec is nearly 90%. And almost all of these patients show no signs of leukemia cells in their body. Today, this one drug is approved to combat 10 different cancers. And now, doctors are asking, could the lessons learned from this miracle pill be one of the keys to preventing cancer? Maybe even in our lifetime.
Now let me be clear, this helped change the whole game. It taught us that cancer can be thought of as a chronic disease you can live with and manage, like diabetes, rather than just a disease that would always kill you. I want you to meet the man whose groundbreaking work saved all of these lives. Cancer researcher Dr. Brian Drucker. Welcome to the show. Thank you. I want to tell Dr. Drucker's story a little bit today because it's so fascinating to me. So you actually had an idea, a crazy idea, that you might actually be able to take an illness that was often lethal and change that around completely. And there were drug companies that actually knew they had some products, but they never thought about connecting those two ideas together. Why were you so passionate about this?
Well, you have to realize that I wasn't just a researcher. I was also a doctor. I was seeing patients in clinic, and they needed something. They were told they had a death sentence. And I was working on a drug in my lab that looked like it had promise, and I wanted to get it to them. And so I needed to become the champion, the voice for my patients. And ultimately, we prevailed. We started our clinical trials, and within 6 months, every single one of our patients were responding, having the blood counts return to normal, and restored to complete and good health. Which is pretty uncommon.
You know, you go down a lot of blind alleys when you're a researcher, and it's impressive. And let me just, to make this clear, it's not just about these wonderful folks who've had their lives changed around. This one drug can treat 10 cancers. Now, here's a list of a bunch of them. Some of you out there watching have these illnesses or have relatives that do, but this is just the tip of the iceberg. It changed the way we thought about cancer. Not, leukemias, gastrointestinal ailments, things we didn't really have a lot of hope for. And Dr. Gail Robos is joining us. She's seen this drug in action. She treats patients as director of the leukemia program at Weill Cornell Medical College. So, Dr. Robos, you call this drug life-changing. Why so?
It was life-changing for the patients, and it was life-changing for cancer research, because all of a sudden there was a brand new paradigm in what we were looking for and how we were going to try to crack the case for other types of cancer. And as you can already see, there are a number of different types of tumors which have already benefited from this amazing drug.
Yeah, I mean, a whole mind shift change, a paradigm shift in how we thought about the problem. It's the perfect word. So this drug was first approved to treat this relatively uncommon kind of leukemia, but it's still seen a fair amount. The real question is, can we unlock the mysteries of other cancers by appreciating how you can treat so successfully one very specific kind of cancer. And I have an animation that I think might be helpful in helping everyone understand why I think this is the case. So if you understand leukemia, you need to look inside the bone marrow. So let's go into one of the biggest bones, the femur bone. And deep inside of there, you've got two things being made by the bone marrow. You've got red blood cells deep inside there, and these are little discs. They carry oxygen around. You all know that. But it also makes white blood cells. These are cells that defend you. They attack bacteria, viruses, and can clean them away. Let's go inside of those white blood cells. Inside the white blood cells, you have chromosomes which carry your DNA, the blueprint of your body. These are half from your mom, half from your dad. They bind together. What if two of these chromosomes cross, and as it happens with this leukemia, they exchange pieces? Now you've got a piece of chromosome that's not supposed to be there. And what if that chromosome is saying, make more cells? Don't listen to what your body's telling you. Make more and more and more of these white blood cells. The next thing you know it, you've completely replaced your bone marrow with all these white blood cells that have grown out of control. That's why leukemia is a cancer, because you've got cells that are sociopathic. They're not behaving themselves. You've got too much of a good thing, which is always a problem. And the question, of course, is the mechanism by which that cell turned on to become a sociopath is driven by that one little switch of chromosomes. If you could identify what that chemical was, and then block it or reverse it or change it, it becomes the pathway to treat a lot of different cancers that we envision. So I want to demonstrate the whole issue about side effects. So Eleanor, will you join me? Yes. Come on up, Eleanor. So this is going to be, I hope, a pretty elucidative experiment. Go on, put your goggles on, Eleanor.